Hello, I'm Matt Van Vliet. I'm here with Kevin Smith, and today we're going to talk about the business value of TDD, or test-driven development. Before we can dig into the business value, let's first talk about what is it. So Kevin, what is your definition of TDD?
So test-driven development has been around in some form since the beginning of code. It became prominently recognized in the late 90s and early 2000s with the extreme programming practice. Around the same time, Agile started to be recognized. The first extreme programming explained book was published in 1999. The concept itself is fairly straightforward, where you just have really short development cycles, sometimes measured in minutes, where you write a simple test, write code to pass the test, and then do some refactoring or do some rewriting or simplifying of the code while keeping the test in a passing state. This cycle repeats until a feature or piece of functionality is complete. So the concept itself is very simple. The difficulty is, that technique is not how software development is taught to people. So in universities, in college courses, in online courses, in boot camps, they rarely teach new developers this approach from the ground up. So instead of especially in higher education system, instead there's a heavy focus on what I call debug-driven development. Students are taught to write a complete piece of functionality all at once, and then they're taught how to use a debugger to see if it works, or see how the code works inside of it. And that is incredibly slow and incomplete. So you get a lot of bugs, you get unused and dirty code. It works to pass an exam, it works to pass a course, but it does not set up developers for success in creating long-lasting projects.
Right, and it doesn't scale, right? So if you're building a small application yourself, that's one thing. When you have teams or teams of
Right.
teams that are building something, you need something that's much more industrial strength, much more solidified. So before we get into the business value around it, um, sometimes you're going to see it as test-driven design versus test-driven development. What's that distinction, and is it important?
Well, the fact that it's named test-driven makes it sound like purely a testing practice, and you do get tests out of it. But in that cycle of really short development pieces measured in minutes, where you're writing a test and trying to get a test to pass, it's forcing you to really think about how your code is structured to make it testable. And by making your code testable, you're getting clean code that's well structured, that has well-defined interfaces, versus a test after practice where you have to go and try and figure it out afterwards and try and clean up a mess.
Right. So test-driven development is a very technical practice, and once engineers learn it, it's very hard for them to go back to writing things the other way. But just like any skill, it's something that takes time to learn and practice. It's also something that's not because it's so technical, it's not intuitive for people to understand the business value of it. So let's dig into the business value of why you would want to write your tests before your code, why you would want to use this technical practice. So at a high level, Kevin, I know we have 5 different areas that we wanted to drill into around test-driven development. Why don't you lead with the first one?
Yeah, we'll go through these 5. There's a lot of overlap between them, but there's still 5 key pieces to the whole thing. So the first one is improved efficiency. Um, ensuring that you have a strict focus on your requirements. So when you pick up a story or you're working on a piece of functionality or a feature, you've got a set of requirements that you're working to complete. And by using test-driven development practices, you are looking at those requirements first to see if they're actually usable. So you get reduced waste, or what we call gold plating, a lot of reduced rework after the fact, and giving you that fast feedback on requirements allows for less costly pivots.
Right. So if you don't know enough information to write the test to say, here's how I'm going to validate it, it goes um, on that you don't have enough information to write the code. A lot of times people get into writing the code before they figure out they have questions, they don't clearly understand it. So by writing the test, making sure that you have the conversation with the people requiring the code, that you understand exactly what you're trying to solve, that first of all is more efficient because you get the requirements more correct the first time, and then you only write the code necessary in order to pass that requirement. If you don't have something that really grounds you to exactly why you're trying to build it, a lot of times what will happen is you end up building in more complexity than is needed, and then you have to maintain all of that complex code for the life of the system. So ultimately, test-driven development is going to make things more efficient, and that kind of goes into the higher level business value, right? A lot of times people think if I'm going to do this, I'm writing all of these tests, I'm learning this new practice, it's actually going to take longer. But once the skills are built in the developers, this is actually going to be much faster. And the number one reason that we just talked about is going to be because we're going to write less code and we're going to spend less time trying to figure out the requirements because we're going to understand and get rid of that risk early on.
The second one is reduced risk. So by catching issues with requirements or code earlier and more frequently, the fast feedback loops, are sometimes measured in seconds. That reduces the future cost of costly production issues or debugging, right? So as you work through in a TDD way, going through the requirements, you're getting really fast feedback on your code and on your requirements.
Right. So there's a risk of getting the requirement wrong. And since we're doing things in this fast feedback cycle, we'll know if we got it wrong real quickly. And then there's a risk when you're adding code or changing code to make a new requirement that you break something that used to work. And when you break something that used to work, um, you're going to know it instantly in TDD because your tests will fail. And therefore, the root cause analysis, you know exactly what change just caused that failure. You can go dig in to see, what was the side effect of this change I made, and why did it break some other area of the system.
Right. The cost of fixing defects goes up exponentially as time progresses from when the defect is first created, because you end up building more and more on top of the bad thing that you have to go back and unwind.
Right. So we're more efficient. There's less risk. What's next?
Overall improved quality. So TDD practices force developers to think about how their code is structured, and this leads to code that's easier to maintain, and adding future features that are defect-free. And this affects, adding, working with other developers, having other developers on your team, having someone come in months or years later to look at your code, make changes to the code. You've got that safety net of all of these tests that you built when you originally wrote the code, that they won't break it in the future, or yourself.
Right. So, there's a quality aspect. I have these tests, I'm not going to have a defect, but there's also a quality of design, right? So
Mm-hmm.
if I write my tests and I have these small measurable tests, that means my code is probably going to look similar to that, where it's going to have single functions or small sets of complexity well designed into it. And by nature, TDD code has to be testable code. A lot of times, if you write a big complex set of code and then you go try to test it, it's not going to be quality code in that it won't be testable. It's not going to be reusable in small chunks, and it's just not going to have the level of design that test-driven code will have.
A key piece of that is dealing with dependencies, right? So you're always going to have dependencies in your code, but how you deal with them, impacts the quality of your code. If you can isolate them, if you can abstract them, so that you can test your functionality separate from the dependencies, you'll end up with higher quality. And TDD kind of enforces that way of doing things.
Right. Okay. So I think as we go through these, you're going to see more and more overlap, because there are valuable pieces of this, but some of them, are just different aspects of the same problem. So what's the next
So
one?
this next one fits right into that: faster requirements validation. So we've talked about this in some of the previous ones, but if you can test the requirements, then you can create code that, production code that passes those tests and meets those requirements. So that's a key upfront benefit. Is you pick up a story card, you look at the requirements, validate first. Can you write tests according to those requirements?
Right. There's actually a lot more defects or rework caused by not completely understanding the goal of what you're building code for than there is that I just wrote the code the wrong way, right?
Mm-hmm.
So developers know, once they know I'm supposed to write a function that does this, they know how to write code to solve that. Knowing explicitly all the different cases and the edge cases of what the business rule is, what the functionality needs to be, is a big piece of writing code. Yeah. So the final one.
And the last one here: cleaner, more maintainable code. So we talked a little bit about this before too. The design practice, as much as it is a testing practice, and this, in my mind, really gets to the team-based aspect to it, or the longevity of it, where future contributors can get up to speed faster, future features can be added without risking the existing features in the system. As long as you're doing the TDD practices appropriately, you actually incorporate the refactor step and not just write the test and write the code to pass the test. You do all three of them. If you're constantly refactoring your code, you end up with a more maintainable code base.
Right. So all of these 5 things are aspects of the value of TDD, right? In the end, what you want to do is make it so that you don't fear changing your code. If you're afraid to change it, you're going to slow down as a team. And if you're afraid to add people to your team, if you're afraid to have different people working in different areas of code, so that fear of change creates friction and slows everything down in software development. And test-driven development gets rid of that fear of change, and therefore you're able to move much faster, and you're able to be much more nimble in your development of your product. And by moving faster and being able to respond more quickly to feedback, ultimately the business is going to be able to deliver value to their customers much more efficiently and much more effectively. So ultimately, while TDD may sound like a technical practice, it may sound like a cost of writing code. In the end, it's an enabler to make sure that your software is truly soft, easy to change, and can move at the speed of your business. And as your markets are changing and your needs are changing, your applications and your software is going to be able to change.
So, Matt, we talk about test driven and test first. Why not test after? Why don't you get the same benefits with test after?
Yeah, there's a few reasons, right? So one, and probably the most significant is you're really not going to write the tests after, right? Because ultimately you get that feature done. Are you going to go back and test after? But there's some things that we just talked about that really are additional benefits. Because if all our only goal was the tests, I could say, well, you can write the test after, and as long as you can create that discipline, you'd be okay. But when you write the test after, your code isn't by default easily testable. You haven't taken the risk out to make sure you understand the requirements well before you invest in building the code, and you don't have that protection that as you're building it, make sure that you're continually moving forward and you're not breaking things that used to work. So test after seems like a a solution to say, well, I don't want to force my people to write tests before they write their code. You're going to lose a lot of the benefits, and you're just going to make it harder. Once people learn how to write code this way, they wouldn't think of trying to write production code before they had something to validate that the code did what they wanted it to do.
And a lot of times developers end up writing more code than is needed with test after.
Right.
And a lot of the corner cases don't get covered in tests. You just test the happy path instead of all the exception cases. So there's a lot of reasons,
Yeah.
and it's much harder. That test after is seen as extra work. You've already got the feature done. Why can't you just get it out the door? You've got to go back and then add all of these tests and find all the corner cases and rethink through your code.
Yeah. And the last thing I'd say on that is it's a little bit of context switching. When you're going to write code, you think about, well, what do I want this code to do? What if I don't have all the data I need? What if there's a problem? And you're thinking through all that as you're writing your code. All we're really doing is teaching people to write tests while they're thinking through all the cases, such that now that's um, executed in the system forever. So now we've captured what was in your brain while you're coding, so that now everyone else has the benefit of that knowledge and it's retained, and the software becomes self-validatable, and it's going to be much better software and much more efficient.
Yep.
All right. Well, thanks for spending the time with us today. I think you have a perspective on why test-driven development is important and how to talk to the business and talk to others about what it's going to do for your organization. In the future, we'll talk more in detail about specific practices and how you efficiently write that code. But in the end, you need to understand why you're doing it and why it's valuable, and get your teams organized around that, and you're going to build much better software that's more resilient and more malleable to future needs.